why the Beam, Elixir, Erlang ecosystem is very good for security, although there are some things that could improve, and we'll touch on a few of them also. This talk is on Prezi. You can find a link to it in the Whova app. If you feel like getting ahead of me, feel free to take pictures, feel free to copy any of it. It's all public domain stuff. The talk's in 5 sections. The first, a little bit of cyber education, some good and bad things about our ecosystem, some things you can do in your projects, some things you shouldn't do in your projects. We'll discuss some open source projects that matter to the security area, and then I'll sum up with some takeaways. So it's just after lunch, we're all a little tired, so we'll start with a little warm-up, then we'll talk some money, talk about CIA, and then talk about Internet of Things. So ask some questions. If your answer is yes, raise your hand. If you answer a second question, yes, then raise the other hand, so we'll get a little arm action going to get things pumping. Have any of you ever been at a conference called ShmooCon? One, very good. So he will know, and all of you don't know, that at that conference, when you register for the conference, they give you all a thing called a shmoo ball. And they don't have the little thing as you walk out the door to say whether you liked it or not. If you don't like the speaker, you throw balls at them. So you guys don't have beam balls, but note that I do. Okay, so you got to pay attention. Everybody in the audience who is aged 41 or younger, raise their hand. The vast majority of you were born after I graduated from college. How many of you have developed some software in the last week? And vast majority, good. Just to make sure everybody raises their hands, how many of you have eaten in the last week? All right, good. Don't forget the switch hand thing. Okay, good. And how many have seen the movie Jerry Maguire? All right, so you'll get this joke. This is from the movie Jerry Maguire. So next I'm going to talk a little bit about money. Look at it from 2 viewpoints. Look at it from the industry viewpoint and look at it from the people who are spending all that money's viewpoint. The cybersecurity industry is currently projected to grow to be $1 trillion industry over the next 5 years. That's trillion with a T. That's a really, really big number. And it's too big a number, and there's some things we can do to make it smaller. But why are people spending all that money? They're spending all that money because they're trying to reduce their risk of losing even more money. So this is a really, really big business. And so remember that you spend the money to reduce the risk, because we're going to talk about that a little bit, from the other side of the coin, from the people who are spending all that money. Why are they spending money on security? Because they're worried about being impacted with a greater loss. So this particular book, I'll actually have to say I didn't like reading it. I don't actually like the writer's style, but it's got some really good concepts in it. So I like it so much, I have 2 of them that I'm going to give away at the end of the talk to the first 2 people who ask me good questions. I'll give you a book, so be thinking of some questions during the talk. And what the book is on is taking the math and science of a lot of other fields that have looked at risk and applying it to cybersecurity. And for whatever reason, as cybersecurity geeks think we're real special and different and have not taken a lot of the advice that this book was written on, so we need to do that. This book is actually used in many college courses as a textbook for the course, so obviously I can't do a full semester's course in the 2 minutes I'm going to spend on it, so I'm just going to touch on a couple points in it. The first being that to do this assessment of risk, there's a lot of subjectivity involved. And we're all humans, and we all have cognitive bias, and there's all the billions of different types of cognitive bias. And a lot of the book is on how to remove the cognitive bias in assessing risk, and basically reducing all your risk down to monetary values. And the particular thing they really like that is a really useful curve that people making security purchasing decisions should know is something called the loss exceedance curve. And again, this came out of other fields, particularly out of the financial field. So if you need to talk to your board about security risks, they understand this kind of stuff. And the way you read this chart is in purple. The point at the end here is there's a 90% chance that you're going to lose at least $10,000 in the next year. So there's, you're spending a certain amount on security, but it's still not going to cover everything. And there's a pretty high probability you're going to lose something. Okay? There's a 50-50 chance you're going to lose at least 5 million. You'll notice it's a log scale. And where it really gets interesting is in what are called the high impact, low probability events. There's a 1% chance you'll lose at least $500 million. Now this particular chart for most companies would be that that red would be a catastrophic event to the company. There are companies that have went out of business because they were hacked. However, if you're a large bank, you would love to have a chart that looked this good. Okay, their numbers are way bigger. So, I don't know if you noticed, but on the slide before I said one of the things we're going to talk about is CIA. In the cybersecurity realm, it does not stand for the Central Intelligence Agency. It stands for confidentiality, integrity, and availability. That's really the core of all security is maintaining those. You don't want people reading your private stuff. You don't want people changing your bank account, and you want stuff available when you want to look at it. If you can do those three things, then you can make a secure system. But those three things are actually hard to do after the fact. You have to build the security in. That's where a lot of our problems are. And so, just like there's an Agile manifesto, there's something called the Rugged Manifesto. It's part of Rugged DevOps, and it's got a whole long list of things. It's got a page of stuff. But the one I wanted to highlight was that when you design, you have to design knowing that evil people are going to try and do something to you, that they're smart and that they're persistent and that they have resources and they're going to want to do something other than what you wanted your code to do. So just take that into account when you design. So we need to design resilient systems. So stolen from another hacker conference where they were defining resilience. And you have to be flexible, you have to absorb the attack, and you have to reorganize around the threat. And this is the kind of things that our ecosystem, we're in a very good position to be able to do these kinds of things. Designing resilient systems is what we do, so we should be playing more in this space. So during my career, we've went from literally computers the size of buildings, that's how big they were when I started, to I have a computer on each wrist right now. They've gotten a lot smaller. They've gotten a lot more plentiful. Cell phones have come about. There's billions of them. Evolved to the cloud, which is sort of another order of magnitude scale of the amount of things we're dealing with. And now the Internet of Things is coming along, upping the scale even more. So we have many, many more things that we have to secure. And they matter more now. It used to be computers were pretty much a work aid. And if they got, somebody hacked into my computer, did something, I'd be embarrassed, but who'd care? It didn't affect anything. Now they're critical to our businesses, but with the Internet of Things, what's even more important, there's the Internet of big things, cars, planes, and trains. You hack into them, it's a bigger deal. There's the Internet of medical things, pacemakers. I actually, sorry, I'm wearing the mics. I went to a HackerCon last summer and learned how to hack pacemakers. You can kill people, okay? So I like to quote Josh Corman from I Am the Cavalry, who says, IoT is where bits and bytes meets flesh and blood. So security is a bigger deal now, and we really have to take it into account. So how are we going to do that? The key is automation. We need to be able to respond to the attacks at the same speed the attackers are attacking us at. I attended RSA, which is a big hacker conference, or a big security industry conference here in San Francisco. It's not really the hackers, it's really the people selling everybody that $1 trillion worth of gear. And heard a great quote, so I used it last year at my talk, but I'm going to use it again. I made some graphics to go with it this year. Our problem is the offense is operating at the speed of light, and the defense is operating at the speed of lawyers. And that's pretty much true, and we need to change it. And it's not that we shouldn't talk to our lawyers, it's we should talk to our lawyers ahead of time. We should, first of all, think of what could happen, talk to our lawyers ahead of time, get permission to be prepared to react to that, build in the reactive defenses to deal with that, and just let the computers do their work, not have it be a reactive after-the-fact event like we do things today. So automation is a win-win because it's both cheaper and better. Johns Hopkins University did a study, a lot of detail, I won't get into all the details of it, but the sort of key fact was when they automated their defenses, they reduced what's called the dwell time, the amount of time the hackers were in their network. They reduced it by 2 orders of magnitude. So instead of being in for a week, you're in for an hour. You can do a whole lot less damage in an hour than you can do in a week. And so it's really, really valuable to automate your defenses. Another key aspect of this automation, though, is we got to get the industry sort of all on the same footing. I'm involved in some standards efforts in Oasis to standardize on something called Open C2. C2 is command and control, right? Firewalls were invented in the early to mid 90s. There's a bazillion types of them, and there's a bazillion interfaces to them. We can't even agree on the word you use to say you don't want the packet to get through. Is it drop? Is it deny? Is it block? And so this is an effort to try and standardize all that, because if you want to automate, you got to be able to, move quickly and switch quickly, and you can't do that if everybody's talking a different language. One final topic under the sort of cyber education, then we'll get into the stuff you care about, is we have a skew more of a carryover that used to be a requirement that isn't there anymore on that bigger is better. In the cloud and the Internet of Things, bigger is not better. Okay, small is beautiful. Again, something our ecosystem is particularly well to play into. But the economics no longer drive bigger is better like they did when you're buying big blocks of hardware. They don't do that when you're buying a slice of time at Amazon or whatever. So let's talk a little bit about our ecosystem. So what makes the stuff we do particularly appropriate for security, and for not only for our code being more secure, but for using it in security projects? Well, I mentioned that security is confidentiality, integrity, and availability. You sort of can't do anything in this ecosystem without somebody mentioning availability in 5 nines or 10 nines and all those kinds of things at some point. That's something we do particularly well. And the underpinnings on how we do that well are actually applicable to the other aspects of security as well. The sort of let it fail, let it crash mentality is baked into OTP, and that's very important, and that helps with the availability. But the parts of it that make it work that way, the actor model, the small lightweight processes, are also very good things for security. Hot code replacement. There have been attacks that were really famous that you read about in the newspaper like 3 years ago that people do studies and say, and the patches for those problems haven't been put in. It's 3 years later and still 20% of the systems are still vulnerable to it. Now, why is that? It's because people are afraid to do the patch, or afraid to put the new thing in. And our ecosystem is much more resilient to upgrades of software. So that's something we're particularly good at, although there's a downside to it I'll get to in a second as well. Now, you all probably think OTP stands for Open Telecom Platform. Let me divert here for a second and say I went to a great talk this morning on why our ecosystem is particularly relevant, but we're not very good at selling it. We're horrible at marketing. I worked for a telephone company for 35 years, and I still think Open Telecom Platform is a horrible name. So I propose that OTP really stands for One Tough Platform. So stop calling it Open Telecom, start calling it One Tough Platform, because that's really what it is. There's a lot of good stuff built into it, and it allows you the capability to build a resilient system, resilient to hackers trying to get in. It doesn't inherently make a resilient system. So many of the traditional attacks don't work against our ecosystem. That's really good. But it's not perfect. If you compromise one node, if you're not careful, a hacker gets into one node, most likely they can get into all nodes. They get into one VM, most likely they can get at all processes. There's some things you have to do to make your boundaries a little bit more secure. I mentioned hot code replacement. Hot code replacement is really good from a patching viewpoint. It's also really good from a hacker code insertion viewpoint. So there's things you have to do to watch for that. And I'm not going to get into all the scary or under the hood stuff in Erlang, but I will say there is a talk, there's a paper, it's called In Defense of Erlang, and it's at that long URL there that you can get off the conference app that has links to all these slides. There was a paper from a couple years ago, so hopefully all of the things that were released in that talk have been fixed by now. Maybe not. But there are things we need to work on and still should do and to make it better. And we all need to think through, there's a lot of from a hacker viewpoint, there's a lot of high value targets in our space. We should be looking at how to protect them. So what can you all do in everyday work to make your code more secure? Again, one of the big takeaways, think evilly, act ethically. And I made that group view graph, and you can copy it and use it all you want. This is nothing new. Sun Tzu 4,000, 3,000 years ago said, to know your enemy, you must become your enemy. That's just a mindset you have to think, but you have to recognize that there are people who want to do something. And so you should think up, if I was a bad guy, what would I want to do, and how would I do it? So you need to build security into what the projects you're doing, and there's books on it, and a lot of it is just that mentality that I just said. A lot of it is just using OTP, and using it meaning actually use it. Don't just say, yeah, I wrote some code and I use GenServer, so I'm done. You have to worry about supervision trees and actually do them correctly and stuff like that. And even if you do all that, it still doesn't necessarily mean you're secure. There's an organization called OWASP, the Open Web Application Security Project. They've been around for a while. They're involved in application security, and every year they publish the top 10 list. So a bunch of them get together and say, hey, what were the big hacks of last year? How did the hackers do it? What were the things, what were the techniques they used? And one thing that was amazing about the 2017 list is it actually had 4 changes to it. Usually it doesn't change at all year to year. But you'll notice the top one on here, injection, that one's actually been on here since the mid-90s. And it's an easy enough attack to thwart if you just design your web interfaces correctly. Correctly meaning you thought about it beforehand and made sure somebody couldn't do that to it. So main message there is, don't just assume because you're using our ecosystem that you're secure. There's still, again, if you thought through how would you get in it, and you read the sort of, and you looked at what hackers do to get into things, you say, well, what could they do to mine? You'd find there are things you could do. And particularly on that one, there's some tools actually in our ecosystem that can help with these things on this list that I'll talk about in a few minutes. So now that you've designed your code, you think against at least all the hacks that you can think of. The next thing you should do is red team it. In cyber, again in the education side again, in cyber, the defense is called the blue team and the offense is called the red team. It's a carryover from old military terms. And you need to actually red team yourself. You need to do it as a in your head exercise when you're designing it, but you need to actually do a real live red team exercise, either as a tabletop exercise, get a bunch of people sit around a table and say, hey, if we were whoever, what would we do to it? But you probably should also involve some outsiders. There's professionals who do this. There's white hat hackers as opposed to black hat hackers are the bad guys trying to get in your system. The white hat hackers are the guys who are willing to help you by trying to get into your system with your permission. They're ethical hackers. You might want to consider involving some of them. And if you care, that red team, I was on that red team. That's my college football team. I am in the front row there, that's literally a 40-year-old pitcher. So you've built your code in, you've built security into your code. You've tested with red teams your code. Are you done? No. There's at least one more and preferably 2 more steps to do. You should recognize that once you go out and go into production, there might still be bugs in there. And you should recognize that it might be good if there's a security hole in your system that you'd let people tell you about it. And that's called vulnerability reporting. So you should have a vulnerability reporting process. You should have an ability for people to tell you, hey, I just got into your system this way, or I think you could be hacked into this way or not. There's even an international standard on how to do vulnerability reporting. ISO 29147, if you want to look up how to do it, and there's lots of literature and stuff like that. It's usually relatively simple stuff. And once you've done that, you sort of acknowledge there might be issues and people can tell you. Not before you've done that, because people have made that mistake. Once you've done that and got that system working, you might want to consider also offering a bug bounty. There's been a lot of success in the area of basically paying people to find the security holes. Because believe me, the hackers are going to find them. So you might as well let the other people find them. It's usually cheaper to pay the white hat hacker than it is to deal with the consequences of the black hat hacker. So next up, we're going to talk about open source. I did a very unscientific study of the amount of open source stuff in our ecosystem. And I did it for Elixir and Erlang, and I did a study on GitHub, and I played around on GitHub, and I came up with around 30 projects. It took me 15 minutes of a few searches. Spent like 2 minutes and said, well, how's that compare to some others? And I did Python and I did Java, where I found 3,000 projects. So we're a little behind, and it's not securities for those systems, it's security for other needs. It's security appliances that other people buy and use for stuff like firewalls and intrusion detection systems. There's just not a lot of that out there, and I'll be talking a little bit more later on that. So I'm definitely cherry picking here in the ones I'm going to show you. Cherry picking in the sort of not good sense of the word, in that I'm going to show you some. Don't assume there's gazillions of other ones just like it or that they're all this good. So I ideally wanted to pick 4 projects to review. One from a hacker, and from a security researcher, and I picked one of them. One, a code quality project, how you can make your code better. One, how to build some security in particular, into some interfaces, a project I really like a lot. Go over that. And the fourth one, what I wanted to do was some piece of that $1 trillion industry that I was talking about, a firewall, an intrusion detection machine, malware detonation, deception technologies, a lot of really good stuff going on out there, none of which appears to be in our ecosystem. So instead, what I'm going to talk about is the gaping holes, and maybe one of you is going to go found the next $1 billion Erlang ecosystem company based on something I said here today. And if you do, throw me a few $1,000 or whatever, I'll be happy. So first up, how to be a better hacker using the beam. So this is, again, a tool that could be used. You got to remember the act ethically part when you're using this tool, because you definitely could do evil with it. It's got a really cool name. It's called Sparrell, because it's a scanner and it's in Erlang. So I liked it just for the name, but it also happens to be a good tool. So what does it do? It's for fingerprinting the internet, and I'll explain what that is in a second. But most hackers use a tool called Nmap. It's a very common tool, and it's for both port mapping and fingerprinting, which I'll explain in a second. And if you do it with this tool, it's literally several orders of magnitude faster, which is good if this is what you want to do. So what is port scanning? Port scanning is just, on this particular IP, is this particular port available for service? Will it respond to a TCP handshake? Because again, the way the internet is configured, because it was designed by a bunch of people who were trusting each other in the original internet networks, authentication, who is sending it, and authorization, are they allowed to, comes much later in the process. First you do the TCP handshakes, then you do the handshakes at the higher level, and then you worry about, hey, am I even supposed to be talking to this guy? And that'll be important for a project I'm talking about in a few minutes. But port scanning is relatively simple. You can do a really lot of them really fast, and Nmap's pretty efficient at it. But fingerprinting is a little harder, because fingerprinting, you're actually asking, what's the actual service running on it? I can assume if it's port 80, it's running HTTP, but maybe it isn't. Maybe it's running SSH on port 80 so that people won't assume that. So to do that, you actually have to do that same sort of handshake, but you have to do it for sort of all the protocols, and you have to do it at the higher level. But if you do it well, you not only get what services are running, you even get what versions are running, which is very useful to the hacker, particularly from when you're looking for, hey, I know that version has a vulnerability. That's going to let me in. So this particular tool is very useful in the red teaming or in the evil hacking that you're doing. So how does Sparrell get this efficiency? It uses an army of concurrent minions in the cloud. Okay, cloud resources are cheap. You can, particularly for a short period of time, your money is much better spent buying a chunk of Amazon than it is buying a computer and trying to crunch it through. And if you use Erlang, you're very good at concurrent processes. You can set this up and be much more efficient than Nmap, and that's how it does it. And if you want to know more than that, I'm not going to be the one to go into the detail for it. You could either A, go read the source, the link to it is there, or there's a talk by the author at a hacker conference, that the YouTube video, the link for that is also there. Excuse me. So the next project is a code quality project, something you could do to make your code better, particularly if you're in the Phoenix ecosystem. Now, I don't happen to like horror movies, so I don't watch horror movies, but this particular project is called So Below, and apparently in the horror movie industry, a movie called As Above, So Below is a really good cult kind of horror movie, so that's why I use that, and plus it has cool graphics, so that's why I use that particular graphic. But what it's for is it's a static analysis tool. It analyzes your code, analyzes your Elixir code as part of Phoenix. I assume most people are familiar with Phoenix, a very good web server project that's sort of one of the stars of our ecosystem. If you're not aware of Phoenix, you should be using it. If you are aware of Phoenix and aren't aware of So Below or a tool like it, you should be using it. Because what it does is it finds those faults I told you before that were on that OWASP top 10 list. So it finds things like SQL injection faults and a bunch of other ones that are on there. And if there's some hackers' ability to get into web servers that aren't on the So Below project, well then you should work on the So Below project and build that into their detection stuff too. But the purpose of this is to help you not fall prey to the kind of attacks that are well-known attacks that are easy enough to thwart by just designing your code correctly. Again, this doesn't fix it for you, it just tells you it's there. You got to go fix it yourself. And again, if you want to know more about it, the code is available to look at. So the next project is one of my favorite projects, and it has a horrible name. It's called FWKNOP. I'll explain why in a little bit later. But recall we talked about Scannerl. Scannerl was seeing if the ports were open, and then seeing once it's open what services were running on that. And that was because even though the hacker machine had not identified itself yet, the way servers work is they sort of don't worry about authentication until you're sort of well into the process. So the US government on some super secret spook projects a number of years ago sort of came up with a concept of, well, hey, what if we didn't let anything in until we knew it was from somebody that we were supposed to receive it from? And you go, well, there's a chicken and egg problem there. How do we solve that? And that's what this project is for. And I'll explain how in a second. But first, I want to give a shout out to Mike Stair and Gary Hodgkin of AT&T for coding this up in Erlang. This particular project has been available in some other language, particularly in C, for a number of years now, and is used in, like I said, in some spooky government projects and in some other stuff. And it should be much more widespread, and it plays really well into our ecosystem. So I really think we should be using it more. So they did some work on it for some work they were doing and put it in their stuff, both the client and the server. And I'll show you where in a second. But first I'll say, what is it? So some of you may remember I gave a talk here in one of the lightning talks a number of years ago on something called SDP, Software Defined Perimeter. When I gave that talk, nobody had heard of it outside of a few of us who were on some committee. It's now grown up pretty big. It's actually grown to be an $8 billion business. It's a pretty big deal, and there's different flavors of it. Google's got a flavor, and the Cloud Security Alliance has a flavor, and somebody else has a flavor. But one common thing to many of the flavors is trying to solve this issue of you shouldn't really be talking to people if you don't know who they are, and how do we do that? And many of them have, as a part of that, something called a SPA packet. And a SPA is not a place you get a massage like it looked like on my other view graph. SPA stands for Single Packet Authentication, which I will now explain, but it's basically the underlying concept is you can't hack it if you can't find it. So what is a SPA packet? Well, it implies you have a firewall, and it implies the firewall is set to not let anything in. And then it's a stateful firewall as opposed to a stateless firewall. And a stateful firewall, once somebody's in and has an established session, you'll let their session continue as long as it's part of that session, but you won't let anybody else in. So it assumes that if you have established sessions, they can continue, but you don't let anybody new in. Well, but how do you get started? How do you get in the first place? And that's where the SPA packet comes in. Outside the firewall, you have something listening. It's in listen-only mode. It's not going to respond. It's just going to tell you whether a particular packet ever happens to knock on the door. This concept of all these packets are hitting and falling away is called knocking. And the ones that are from the person that is allowed to that has shared a secret with you in the past. So they're a client of the server that will eventually come in, so they somehow have a shared secret, and they do some fancy cryptological stuff that they make a particular kind of packet that's reasonably easy to detect, at least for crypto stuff. It comes in on a particular port. You don't have to advertise the port, which is security by obscurity, which is not a great security mechanism, but helps a little bit, keeps the ankle biters out. But the real security part of it comes in the shared secret and the cryptological one-time password that's sent as part of this SPA packet. And when you get that packet on this sort of random port, then the server tells the firewall, oh, okay, that is Duncan coming in. He happens to be at IP address 1234 now. For the next minute, open up the door to let him on, just from that IP address, establish a session. And if I can get through the firewall, then get through the rest of the authentication on the inside to get that session established, then I can keep my session up and go from there. And so this weird name, because there's a firewall involved, that's the FW. Because there's knocking involved, you're knocking on the door, that's the KN, and OP is for operations. It's firewall knocking operations. Again, the only people worse at naming things in our community is the security community. So, but really good project. To actually understand how it all works, there's all sorts of real fancy crypto involved, and crypto makes my head explode, so I'm not going to get into the details of it, but there's plenty of papers on it and stuff like that you can go read. And again, kudos to Mike and Gary for bringing this into the Erlang world. The source code for it, you look closely at that, you'll see that it's not the master branch of the FWK and OP project. It's still got a pull request in to the people who maintain it. They don't know what Erlang is, and they're still trying to figure it out. But on Mike Stairs' GitHub server, on a particular branch called the Erlang server branch, it has both the client and the server. The client's actually into the main FWK and OP code, but the server right now is only available here. And it is the crypto half and the port knocking half of the server. It doesn't have the fancy go tell the firewall to open the port stuff up. You can just use the regular FWK and OP stuff for that, or maybe one of you wants to do the extension to include that stuff in the Erlang code. That would be great. And it would be really great from, I keep touching the mic, sorry. It'd be really great from my viewpoint if when that got done, it got done with that OpenC2 interface that I was talking about on the previous slide. I'm actually hoping to do some of that myself. So next up, let's talk about the gaping holes in the industry. Like I said, it's $1 trillion industry in selling security stuff, and not a whole lot of it ours. And yes, you could claim WhatsApp is part of that $1 trillion. It's a whole $1 billion of it, which a billion's a really big number, but it's only 1/1000th of a trillion. It's still pretty small, actually. And it's in our sort of wheelhouse. It's in messaging. It's not in the classic security appliance where most of the $1 trillion is, which is firewalls and things like that. So there's a lot of opportunity here. I would make an argument that a lot of these open source projects should have an equivalent project in our ecosystem, or we should do wraparounds around some of these projects. Put a port in and put some of this, particularly some of the stuff that's in C, just do a port around it and then put the Erlang ecosystem around them. I think there's a crying need for that, because as I said before, I think we're really good in this space and we don't evangelize like we should. We don't go after some of the opportunities that we could here. So there's firewalls, there's a whole long list of them that are open source. There's intrusion detection and protection systems, a whole long list of them. I put Cuckoo in there. Cuckoo is a malware detonation tool, so that if you found some malware that someone's sending into your enterprise and you want to figure out what's it actually doing, you use Cuckoo, which is just something, the way it works is just something that just screams at me that would be great, and our ecosystem could do that better. I put Infection Monkey in. Infection Monkey is part of the Simian army, like Chaos Monkey, and it's for deception technology. Really hot thing in the security world right now is deception technology. You want to increase the work factor for the hacker to not realize that he's not really in where he thinks he is. He's really in some walled garden you've established, or some sandbox, or you're leading him down the primrose path. That's, again, the type of stuff that, again, we're good at messaging. We're good at small, lightweight processes. The actor model it's a natural for some of that. I included Tripwire, which is an open source project to be able to tell if your code has been changed in an operating system, just because it's an interesting problem for our community, because we do have hot code swapping. So how it would work in those situations I thought was interesting. And I included Security Onion just to make people aware of it. You may be aware of something called Kali Linux, which is sort of the hacker toolkit. You buy a Linux distribution that's got all the hacker tools in it. Security Onion is the blue team equivalent. It's all the defensive tools. It just seems to me we should have a toolkit of our own, like Security Onion, of things that would operate in the Unix world. I think I might be doing well here. So in the last section, we'll just talk about all the things I've already talked about a little, go into them a little bit more. So I do recommend reading the book. I will have, like I said, 2 of them as giveaways in a few moments. And don't blame me if you don't like it when you read it. Like I said, I get nothing from these. I think it's got great concepts. I'm trying to promote that the concepts get used. Even if you don't care about security, the cognitive bias stuff in there is actually really interesting. And basically the fundamental premise is everything should be turned into probability distribution functions of either dollars or deaths. If you're doing Internet of Things, maybe you don't put millions of dollars here, maybe you put the number of people who die in a low probability but high impact event of everybody with a pacemaker died tomorrow or something like that. You really should worry about that sort of stuff if you're in the medical space. If you're in the automotive space, you worry about car crashes. If you're in the train space, you worry about train crashes. If you run an oil refinery, you worry about, hey, if you change the valves this way, the whole thing goes boom. People need to worry about that kind of thing. This example I show here is a little fancier than the one I showed before. It's 2 choices, a red line and a blue line. It's a pretty obvious choice. You should pick the red line. Real life cases might not be quite as simple as that, because it might be the red line costs $1 million. And you have to decide, is that worth it? Is that value of security increase worth $1 million? Or more often, the lines might actually cross. It might make your short-term, your high probability events less likely, like this one. It'll increase the chance of no loss at all from 15 to 30%. That's a really good thing, but it might do that at a cost of increasing your chance of a $500 million event from 1% to 2%. You'd say, well, how could that be? How could it make the security worse? Well, it could be you're using a particular product, and the product, you're sort of betting the farm on that particular product, and maybe it's from a country you don't totally trust, or maybe it's from everybody you totally trust, but it doesn't matter. You're putting all your eggs in that basket, and if that gets compromised, that's going to be the issue. Things I learned when I worked with the military on this stuff is the first thing the Air Force takes out any attack is the enemy radar. The security systems are the first thing the hackers go after. So if there is a hole in the security system and you're counting on it, you could actually increase the devastation of the effect. So you have to be careful of that. We need to extend the let it crash, let it fail, to let it be hacked. We have to build that into our mentality. We have to use one tough platform. We need to call it that. We need to get better at our evangelization. We need to think evilly and act ethically. I'll get into red teams in a second. So when you build your code, recognize that people are going to be doing what they're going to be doing. Think about that and take that into account. Once you've done that, you still need to do the exercises of, basically as part of test, validate that you have to need a red team yourself, and do it yourself, but ideally get others to help you with it as well. Recognize that even after doing all that, there's still going to be bugs out there, and have an ability to let your customers and white hat researchers and anybody else tell you about it, so have some sort of vulnerability reporting. And ideally, reward the people who do that. Because if you reward the people who do that, probably more of them will do it, and you'll probably find more things. There's been a lot of success in the bug bounty field of people who've done them, but there's been some spectacular failures as well. You don't want to do a bug bounty program if you haven't already gotten the kinks out of your vulnerability reporting system. If you know you got 900 gaping holes in your software, don't go offering a bug bounty program. You got to be in pretty good shape before you do that. It's for when you think you've found everything, that's when you want to do it. Use the projects that I was talking about. Whether you want to use Scannerl or not, we'll leave that one up to you. But definitely, if you're building any sort of interfaces of things that you aren't necessarily doing a public interface, you're building a bunch of servers, one of them talks to the outside world, the rest of them talk to themselves, you want to put something like FWKNP on that server. And even on your authenticated user stuff, you might want to consider using it. It's very simple, it's easy enough to do, and it hides you from the hacker. It's a very good thing. If you are working on a Phoenix project, you should be running code scanning tools like Sobolo on it to make sure you're not making that you found all the issues there. And if you got nothing else to do and feel like making $1 billion in your spare time, there's a really lot of money in cybersecurity right now. There's a really lot of things needed, and we're in a really good position to do it. People talk about why isn't everybody using Cowboy, or why isn't everybody using Phoenix? And why should they would be the answer. And if we could solve that, sort of make it the absolute most secure by orders of magnitude, put the FWKOP in front of it, you now have a secure web server that leaves everybody else's in the dirt. It's a whole new field. But we also need to get into we don't need to, there's a huge opportunity to get into the space of all these vendors selling security appliances could be replaced by stuff we'd all come up with. We need to automate the defenses. We need to be operating at cyber speed. And we're, again, in a particularly good position to do that. So recapping my 2 main points. 1 tough platform, use it. And think evilly, act ethically. And I'm going to close with a quote from Dan Geer, who's a cybersecurity thought leader. There is never enough time, so thank you for yours. And we should have plenty of time for questions. So 1, 2 were the first 2 hands I saw. So yes.
So do you think that we should be adding something like a hardened beam where you effectively, once you deploy it to production, certain aspects are no longer available or only available under certain circumstances? Some processes can't talk to other processes indiscriminately. You can't dump process state. You can only reload code if it's signed by the same key as the previous version of the module. Like those sound like really, like once you get into the beam, it's wide open. So like we should
right.
be doing more. You think we should be doing more in that?
Yes. So first of all, I think you should be evaluating that in your application, is that a risk? Okay, and if in your application that is a risk, then you sort of have 2 choices. One choice is can I redesign my application to be more actor model-like even at the next layer up, I'll say. So yeah, all right, instead of having 1 VM, I have 3 VMs, and they got to interact through a known secure interface. So if I do take over one, it doesn't take over the other. That's, I'm going to say, probably the cheaper answer if it's just you and you're doing it. But should we as a community be looking at the threat to solving that problem, I'll say generically, yes, we should. And what exactly techniques and which are the right way, probably you and many others in the room are way smarter than me at doing that, but yes, we should be. So I actually think both are the answer, and we sort of we have to do the second one collectively, but the first one, you should at least be doing the first one on anything you're doing. And again, it's a look at the threat and decide on what it means to you. Who was the one who had the hand? I think it was the front,
For FWKNP, I may have misheard you, but can you repeat or clarify, are one-time passwords the expected security pattern, or is that just one particular?
Okay, so like most crypto stuff, it's complicated. So the fundamental concept is the client and the server have a shared secret of some sort. Could either be a true shared secret or it could be a public key kind of thing, but they have some way, they both know of the existence of each other and they have some cryptographically secure thing they know that they can then make the SPA packet. Now, one of the things in the SPA packet is an HMAC, which is a type of one-time password created from the shared secret. And it's got some fancy stuff in it, so you can't do replay attacks, and we're now at the edge of my crypto understanding. But yeah, there's papers on it. Like I said, the FWKNOP concepts have been around for a while. It used to all be classified. No one was allowed to know it, and they unclassed it a few years ago. And it's in certain projects now that are, well, the government still uses it a lot, but it's catching on a little bit more in the commercial world. Because again, it's if you want to be there's another one of those, like guns, can be used for good or evil. I think there's way more of it in the dark web bad guy side than there is on the good guy side at the moment, but it is in use. Yeah.
Unfortunately, all the time we have
Okay.
questions, but I'm sure you'll be around.
Yes, I'll be around. Thank you.
Thank you.